All right, we're going to talk unit circle today. You should have this in your notes. If not, I will make a copy down below to a link. This, what you see before you, is a unit circle. It has all reference angles of 30, 60, 45 degrees, things that should sound familiar. And we are going to use this kind of as a graphic organizer to help us know a whole bunch of information, of which we are going to talk more about in future days. But the first thing is that we're going to do is we're going to kind of go through and set this up. And we're going to focus on quadrant 1 first. So I'm going to do a zoom in over here. And the reason why it's called a unit circle is the radius is always going to be 1. Okay, it's 1 unit, not anything specific. It's just going to be 1 unit because everything is going to come back to ratios here. All right. So first things first, if this is 1 unit right down here, we know that this is going to be 0 degrees. And then we're going to go up here. This one will end up being 30 degrees. This is going to be 45 degrees. And these are all the reference angles. This is 60 degrees. And then last but not least, 90 degrees. And the reason why we use those is because those are tied to our special right triangles. And then those are going to have nice values that we're going to use. And then those are going to allow us to use some trig from there on. Now, before we get too into this, we are going to go through, and I'm going to do this in a different color. So if you have 4 different colors, that would be brilliant. We are going to write down what the radians are. So up here, I'm going to put down a key. So blue is degrees. Degrees. Nice. Red is going to be radians. So 0 degrees is 0 radians. 30 degrees corresponds to, if I multiply that by pi over 180, 30 over 180 is 1 over 6. So this is going to be pi over 6. 45 times pi over 180 is going to be pi over 4. 60 degrees times pi over 180, 60 over 180 is 3, or 1 over 3, so that's going to be pi over 3. And then 90 times pi over 180 is going to be pi over 2. So again, just as a reminder, angles measure this angle right there. Radians measure this arc length. So it's going to actually measure this length right there in a very general sense. Okay, so it is pi over 6 radians. So it's pi over 6 times whatever the radius is going to be. So now the next thing we're going to go through and do is we're going to find the coordinates of the point. So we're going to have our x value and our y value. Now the two easy ones are this. If I go down over here, this point, since it is 1 radius away, is going to be 1, 0. The next easiest one is going to be up here at the 90, which is going to be 0, 1. Now, if I'm talking that this angle right here is 30 degrees, I'm going to drop an altitude here. Altitude, by definition, is a right angle. And we know the radius is 1. And if you want to, you may want to even just draw like a little, and do this maybe on a separate sheet of paper. A little 30, 60, 90 triangle here, right? So if that has a radius of 1, the short leg is twice that. So the short leg is going to be opposite 30. So that's 1/2. The long leg is 1/2 is the short leg times √3. So that's going to be √3 over 2. So because of that, that makes my x value the long leg, and the y value is my short leg. Great. Again, we're going back to the 30, 60, 90 triangle. Short leg is going to be 1/2 the long leg, or 1/2 the hypotenuse. The hypotenuse on all these are just 1 general radius. For the 45 degree reference angle here, We're going to, again, drop another altitude. This is a little bit harder to see, so I'm definitely going to go ahead and put this one out over here. If I can make the 90 degree. There we go. That looks a little bit better. So that's going to be 45. So this is going to be 45. Hypotenuse is still 1. So now the question is, well, wait a second. The hypotenuse is usually leg times root 2. So if this is my leg, and 1 is equal to my leg times root 2, we are going to solve for the leg, right? So, make sure I have enough room here. And I'm going to erase this eventually. But so I've got 1 equals leg times root 2. So I'm going to divide both sides through by root 2. So 1 leg is equal to 1 over root 2, but we can't leave it like that. We're going to rationalize it. So leg is going to equal root 2 over 2. Now the cool thing is that since it's a 45, 45, 90 triangle, that's going to be for both of those. Both legs. So that means it's going to be root 2 over 2, comma, root 2 over 2. Again, 45, 45, 90 triangle, special relationships between the legs and the hypotenuse. So then, since we have the hypotenuse, we're going to go ahead and solve for, actually, you know what? We're going to solve for the missing leg. Now, for the 60-degree angles, this is going to look really familiar. Drop in altitude. Here's my 60 degrees. Oops. And now remember, that's this whole angle. And so again, I'm going to draw this separately up over here. So it's a little bit easier to see. 60, 30. Hypotenuse is still 1, which means my short leg is still 1/2. It also means that the long leg is still the short leg times root 3. So that is going to be root 3 over 2. Now notice, same thing as what's going on with the 30-degree angle, except that my x and y coordinates are now reversed. And I get that. So again, this should seem familiar, but a little bit off, but that's okay. I shouldn't say a little bit off. It should seem familiar. If it's not quite there, that's okay. Now, as I said before in class, notice this. Everything in terms of the coordinates are 0, 1/2, root 2 over 2, root 3 over 2, and then 1. Okay. Ooh, somebody should have yelled at me. I'm sure some of you did. Those two should have been reversed. My apologies. Good catch. Now, the other thing to remember is, so if you remember that those are your 5 values, 0, 1/2, root 2 over 2, root 3 over 2, and 1. And remember, that's effectively it's 2 over 2, which is 1. And that's the order that they go in, from smallest to largest. So I start with 0, I get 1/2. Root 2 over 2 is bigger than that because root 2 is bigger than 1. Root 3 over 2 is bigger than root 2 over 2. And then 1. You can kind of get a sense of that because, I mean, watch what happens. This obviously is not a big y value. This is a y value. This one's bigger than the previous one, right? This one's even bigger than that. And then this one's the largest. So you can put them in order. Okay. Now we are going to transfer this information over to the bigger unit circle. So give me a second to catch up with you. I'm going to pause it here. Don't go anywhere because it's going to be instantaneous for you. There we go. Boom. See, told you. And again, remember, we've got blue is my angle. Red is my radians. And then we've got our endpoint there, which we'll define here in a second. Now, let's do this over here in quadrant 2. We're going to talk with degrees first. Now, in quadrant 2, this angle right here, that goes, well, hold on. Before we do that, let's go ahead and talk about the axis. That might be the easiest thing to do. This is going to be 180. Not a surprise. Radians we know because that's going to be pi, because it's 2 pi radians all the way around, so it's going to be pi, where you take, 180 times pi over 180, and you get pi. And I'm going to guess you can probably figure out this is going to be negative 1, 0. This angle right here has the same degree measurement, same reference angle as this angle right here. Right? 30 degrees, 30 degrees. Let me ask you this. Up here, we have this point. What do you think the coordinates of this point are? Right there. So with that being in the back, let's talk about this. So if this angle right here is a 30-degree reference angle, that means that this angle here is going to be 150 degrees, right? So we'll fill in all the angles here first. Which would mean that this angle is a 45-degree reference angle, which means that 180 minus 45 would give me 135 degrees. This angle here is a 60-degree reference angle as it matches up with here. So 180 minus 60 is going to be 120 degrees. Now, in terms of the radians, you could go through, in fact, you could go 150 times pi, or pi over 180 and get 5 pi over 6. That's fine. You could also think of it as, since this arc length is going to match up with this arc length, this is pi over 6. What is 1 minus pi over 6? 1 minus pi over 6 is going to be 5 pi over 6. Again, you could go 135 over pi 180, or think through it. If this arc length is pi over 4, what is 1 minus pi over 4? Well, 4 minus, you'd have 4 pi over 4. So all of a sudden now you're going to have a little bit less. This is going to now be 3/4 pi. 3 pi over 4. Likewise, somebody didn't catch this. You're all fired. I got too excited. Let's do this. All right, so this would then become 2 pi over 3 for similar reasons. 120 over 80 is 2/3, or you're taking pi over 3 away from pi. Now, in terms of, and this is kind of where I was starting, but we're going to finish here. Now, remember, everything in quadrant 2, what are the coordinates here? Everything in quadrant 2 is going to be, has a negative x value, right? This is a negative x value, and it has a positive, so negative x and positive y. So the coordinates will be the same. Now, again, you can reflect, like I could reflect this point. So let me do it here. This point corresponds with this point, which means that they're at the same height. So that means their y values are both going to be 1/2. Now, since it's also a 30, 60, 90 triangle, right? You also know that this is going to be √3/2. But now, since we're in quadrant 2, it's going to be a negative √3/2. Same thing as what we had over here. We're just reflecting it up over here, and so that means that the x values become negative. The y values are going to stay the same because they're in the same height. So that means that this point up over here is going to have a coordinate of negative √2/2 and √2/2. This point here is going to match over here. And again, since you're reflecting it over, x becomes negative, so it's going to be a negative 1/2 √3/2. We're going to continue to do this reflection. Now we're going to take those points and reflect them down below. Okay. So if I go down into quadrant, let's go over in quadrant 4. So if this point gets reflected down here, that's the same x value. The y values is what's switching. So this is going to still have, so the x value stays the same, but now since we're in quadrant 4, the y values are negative, so that's going to be a negative 1/2. For your 45-degree angle, that's going to reflect down to here. Again, the x value stays the same. We're going to get the opposite of what the y value is because we're, again, down where y is negative. Likewise here, I get 1/2 and a negative √3/2. And then last but not least, I'm going to get 0 and negative 1. The angles are just about the same. This is 30 degrees, this is 30 degrees. So that has to be 30 degrees less than 360. So this is going to be 330 degrees. What happens if I have a 45-degree reference angle? The distance all the way around then is going to be, not like that, 360 minus 45, so that's going to be 315 degrees. And you're going to do the same thing up there with the 60. So this is going to become 300 degrees. And we all know that this one's 270, so we're not going to worry about that. In terms of arc lengths, you could convert 330 times pi over 180, and you're going to get 11 pi over 6. You could also think of it this way. This point up over here is actually also, oops, wrong color. If I go all the way around, this radian measure is actually also 2 pi, right? Just like this angle measurement is also 360 degrees. So just like we took this angle of 30 degrees minus the 360, I'm going to take this arc length, which matches up with this one, of pi over 6, away from 2 pi. 2 pi is also known as 12 pi over 6. So this is just going to end up being then 11 pi over 6. What happens if I have an reference arc length here? Well, it matches up with this one. That's going to be pi over 4. Subtract that from 2 pi. 2 pi in terms of fourths is 8 pi over 4. 8 pi over 4 minus pi over 4 is going to be 7 pi over 4. This turns out to be 5 pi over 3. This over here then is going to be 3 pi over 2. Or sometimes people with this one think, well, wait a second. Every 90 degrees is half a pi. So here's half a pi, here's 2 halves pi, here's 3 halves pi. Actually, that's another way to kind of go through into it too. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, and 7 pi over 4. All sorts of different ways. All right, quadrant 3. Angles are probably the easiest. I have a 30-degree reference angle here. So I add that onto the 180, just like we did back with reference angles. So 180 plus 30 is 210. I have a 45-degree reference angle after the 180. So 180 plus 45 is 225 degrees. And I've got that one too, a 60-degree reference angle. So that is now 240 degrees. And again, for radians, same idea. You could go through and you could convert each of those angle measurements to radians. Or you could say, well, wait a second. I know this length is pi over 6. Oops, wrong color. I want my magic pen for that. This is pi over 6. That means that this is pi over 6. Pi is 6 pi over 6. So 6 pi over 6 plus pi over 6 is going to get me 7 pi over 6. 225, I can multiply by pi over 180, get 5 pi over 4. You could also reason your way through it. Hey, This is pi over 4. This is 4 pi over 4. There we go again. So 4 pi over 4 plus pi over 4 is going to give me 5 pi over 4. And likewise, for the last one, we've got pi over 3 here. And I've got 3 pi over 3 here. So 3 pi over 3 plus another pi over 3 just gives me 4 pi over 3. The points again, now we're just going to reflect. You can pick them from either area or quadrant 2 or quadrant 3. But again, remember, here's my short side, right? Oops. I've got 3 different lengths that we're going to talk about. I've got this y value, and this y value, and this y value. Well, which one's the longest? That's going to be the 3 pi over 3, right? So that means that the 1/2 has to go here. Now, likewise, as I'm going out here, this is the longest long side, and then I've got this one that's shorter, and that one's shorter yet. So this length of x here has to be the longest one of those. So that's going to be root 3 over 2. Now remember, since we're in quadrant 3, both parts are going to be negative. Or again, you could also reflect it. This point is reflecting down here. It has a negative x value, but now we have a negative y value. So now I have negative root 2 over 2 and negative root 2 over 2. Likewise, I have a negative 1/2 and a negative root 3 over 2. And that's your unit circle. Why do we do this? I'll tell you why here in a second. Pause is needed if you're trying to go through and just take a second. Pause this. Double check that all of your parts are correct. I will do the same. Okay, why do we do this? Let me show you. I'm going to jump over to the other. I'm going to focus here in quadrant 1 and fix my little mistake from before. All right, quadrant 1. I'm going to drop this triangle. Let's take a look at this. So for 30 degrees, I know my radius is 1. What's your cosine of that side? Using that triangle, so cosine of 30 degrees is equal to my adjacent side over my hypotenuse. Well, I know my hypotenuse is 1. What's my adjacent side? How long is it from here to here? Oh, that's going to be whatever that, wait, that's root 3 over 2. Oh, yeah. What's root 3 over 2 divided by 1? Oh, that's just going to simplify to become root 3 over 2. Because anything divided by 1 is just itself, right? What's the sine of 30 degrees? Oh, that's opposite over hypotenuse, Mr. Hayes. You're right. So what's the opposite? We know my hypotenuse is 1. What's the opposite side over here? Oh, that's 1/2. Oh, okay. Have you ever seen these numbers before in relationship to 30 degrees? Oh, yeah. Take a look at this. This is crazy. Hey, check that out. 30 degrees. The x value is root 3 over 2. The y value is 1/2. Otherwise known as, hey, look, this is cosine of 30 degrees, sine 30 degrees. Does that work for every angle? Let's take a look. If I make, let's talk about 135 degrees. So there's my triangle, right? Hypotenuse is 1. What are your other two sides? Oh, this is root 2 over 2. This is negative root 2 over 2. Great. If I ask you for what the sine of 135 degrees is, which is right here, what do? We're going to use our reference triangle. Here's my opposite. Here's my hypotenuse. So the sine of 135 degrees is root 2 over 2 over 1, which is the same thing as root 2 over 2. So it turns out that not only do you have your coordinates, but the x-coordinate is always going to be cosine, and your y-coordinate is always going to be sine. So the coordinates of your points for each of those angle and radian measures actually also then turn out to be the cosine and sine of the corresponding angle and radian measures. So now, if you can more reuse this, if I say sine of 315 degrees, you'll be like, oh, that's negative root 2 over 2. Because sine is always going to be my y value. If I ask you for the cosine of 225 degrees, cosine's x. Oh yeah, that's the, there we go there. If I ask you for the cosecant of 30 degrees, you're like, oh, cosecant, that's related to sine. Sine's 1/2, so cosecant's going to be 2. So what we're going to do this week and a little bit into next is we're going to talk about how we can use this to be able to quickly find sine values that we don't. And worst case is that if you don't remember it, you can draw yourself the little reference triangle. But we'll talk more about that tomorrow. So this video has gone on way longer than it probably should have, but it's still very, very helpful. So we're going to go ahead and end it here. We thank you for everything that you're doing for us, and we will talk to you soon. Goodbye.